Hello dear students, welcome into the third lecture on comparative chemistry of main group elements. Myself, Mr. M.S. Bale, I am working as an assistant professor at Gokhale Education Society's Arts, Commerce and Science College, Jawar. So, in previous lecture, we have learned the main group elements and its metallic and non-metallic character. So, in today's lecture, we are going to learn the oxidation states and electronegativity of the main group elements. So, for that, you must know all the groups, group 1, 2 and from 13 to 17, this group and its element you must know for the purpose of this oxidation state and electronegativity. The residual charge left on the central atom when other atoms of the compound are removed in their usual oxidation state is called as oxidation state of an element. Oxidation state of elements depends on the number of electrons present in its valence shell. See, suppose we will consider the boron. Its general electronic configuration is ns2np1. That means in case of boron, its outermost shell there is three electrons. That is ns2np1. That is total 3 valence electron. That valence electrons, or you can say on that valence electron, the oxidation state will be depend of that particular metal or atom, or you can say element. Okay. Oxidation states of main group elements are shown in following table. That table I will show later on. The S block elements means group 1 and group 2 show only one stable oxidation state. See, S block elements, in S block element there are two groups, that is group 1 and group 2. See, group 1, its element will be the hydrogen, lithium, sodium, potassium, rubidium and cesium. These are the group 1 element. The group 1 element show +1 oxidation state, and group number 2, its element beryllium, magnesium, calcium, strontium and barium. These are the group 2 elements. These element shows +2 oxidation state. See, all the elements of group 1 show oxidation state of +1 because of what? They have one electron in their valence shell. As we know, its outermost electronic configuration is what? For group 1, that is ns1. ns1. So that means all the element from the group 1, in its outermost shell there is only one electron will be there. See the example, first one, lithium. See, in this lithium, the valence electron in this lithium is C. This is only one. Actually, the atomic number of lithium is what? 3. That means 1s2, 2s1 electron. That means in its outermost shell there is, see this one, only one electron. When it lose that one electron, it acquire lithium plus charge. Okay. Then in lithium there is only two electron will be remaining, one will be lost. This will be possible in case of lithium, but when we lose that two electron also, that will not possible. Okay, that means in its nucleus there is outer electron, there is will not possible in case of lithium 2 plus. So that possibility not possible in case of lithium 2 plus. So that means the group 1 element show only plus 1 oxidation state, while in case of group number second it show plus 2 oxidation state. That means from the group second, the outer two electrons, that is ns2, that will be lose, only lose, and remaining will not lose. See the example beryllium. This beryllium atomic number 4, that is 1s2 2s2. Okay, see when beryllium lose these two electron, then it acquire beryllium plus 2 charge here, and only two electrons will be remaining. So that means from the group 2 only two outer electron will be loose, and remaining will be remain as it is. Okay, so in case of this is m, m stand for either magnesium, calcium, strontium, barium, radium. In case when it lose two electron, then its electronic configuration is what, ns2 np6. So that means it's completely filled, there is no chance to lose the electron or gain the electron. So that means the group number second will be show only plus 2 oxidation state. Okay, so oxidation states and inert pair effect. So what is mean by inert pair effect? The inert pair effect is the tendency of the two electrons in the outermost atomic s orbital to remain unshared in compounds of post-transition metals. Or inert pair effect is what? The reluctance of the valence s electrons or ns2 electrons of the heavier elements of p block to take part in bond formation is called inert pair effect. This happens because of ineffective shielding of these electrons by inner orbital electrons. ओके, तो इनट पेयर इफेक्ट क्या है? इसमें क्या होता है, जो भी वैलेंस एस इलेक्ट्रॉन और ns2 इलेक्ट्रॉन जो भी होते एलिमेंट के, वो किसमें पी ब्लॉक एलिमेंट में जो भी हेवियर एलिमेंट होते उसके आउटर में शेल में जो भी वैलेंस इलेक्ट्रॉन, दैट मीन्स ns2 इलेक्ट्रॉन जो भी होते, वो हिस्सा नहीं लेते किसमें, टू द फॉर्मेशन ऑफ बॉन्ड. किस वजह से? बिकॉज ऑफ व्हाट? ineffective shielding of the of that electron by inner orbital electrons. This is the reason behind that. इसके वजह से ns2 जो भी इलेक्ट्रॉन रहते हैं हेवियर एलिमेंट के आउटर मोस्ट शेल में, वैलेंस शेल में, जो हिस्सा नहीं लेते हैं किसमें, बॉन्ड फॉर्मेशन में, उसको क्या बोलते हैं हम? इनर्ट पेयर इफेक्ट. ओके, सो the elements of group 13 which is coming under p block element, its general outermost electronic configuration is what? ns2 np1. This is the general electronic configuration of the group number 13, that is boron family. In case of group 13, what are the element? Boron, aluminum, gallium, indium, thallium. If only np1, that means last one single electron take part in bonding, the oxidation state is +1. that means group 13 के जो भी एलिमेंट है उसके आउटर मोस्ट शेल में जो NP1 सिंगल इलेक्ट्रॉन जो रहता है अनपेयर्ड, जब वो हिस्सा लेता है इसमें बॉन्डिंग में, तो जो भी एलिमेंट रहता है वो उसकी ऑक्सीडेशन स्टेट कितनी होती है, +1. एंड इफ ऑल थ्री इलेक्ट्रॉन्स दैट इज NH2 NP1 टेक पार्ट इन बॉन्डिंग, द ऑक्सीडेशन स्टेट इज व्हाट, +3. दैट मीन्स जो भी है NH2 और NP1 ये तीनों एलिमेंट जो जब भी हिस्सा लेते हैं बॉन्डिंग में, तब उस एलिमेंट की ऑक्सीडेशन स्टेट क्या होती है, +3. Hence, expected oxidation state of these elements are +1 and +3. See, that means group 13 element show only +1 and +3 oxidation state. इसमें बोरॉन +3 दिखाता है, एल्यूमिनियम +3, गैलियम जो होता है वो +1 एंड +3 दिखाता है, इंडियम थैलियम आल्सो +1 and +3. However, to have M3 plus ion, the energy required to remove 3 electrons NH2NP1 is very high, hence the tendency to form trivalent cation is less. See, जब भी ये जो तीनों वैलेंस शेल इलेक्ट्रॉन होते हैं इसके आउटर मोस्ट शेल में, वो तीनों के लिए जब रिमूव करने के लिए जो भी एनर्जी लगती है, दैट मीन्स आयनाइजेशन एनर्जी जो भी लगती है, वो बहुत हाई होती है एज कम्पेयर टू दी forward to single bond formation. So trivalent cation formation will be very less. Now the group number 14, which is having outermost electronic configuration is what, NH2NP2. इसके एलिमेंट क्या है ग्रुप नंबर 14 के, दैट इज कार्बन फैमिली एलिमेंट्स, कार्बन, सिलिकॉन, जर्मेनियम, टीन एंड लीड. Okay, these are the elements which is coming under group number 14. Therefore, it is neutral for these elements either to lose 4 electrons or gain 4 electrons to attain stable electronic configuration. The energy required to lose 4 electrons is very high, so total ionization energy for 4 electrons does not permit these elements to form tetravalent positive cation, that is M4+, as so much energy is not available during chemical reaction. Okay, so we have seen group number 14. In case these group number 14 elements show either +2 or +4 oxidation state. Now we will move to the group number 15, that is nitrogen family. See, its electronic configuration, general electronic configuration, NH2NP3. So the common oxidation state of elements of group 15 are +3, +5 and -3. These are the common oxidation states. That means these three oxidation states show all the elements from the group number 15. The stability of +3 oxidation state increases and that of +5 oxidation state decreases from nitrogen to bismuth due to inert pair effect. See, जब +3 oxidation state बन जाती है किसी भी एलिमेंट की फ्रॉम द ग्रुप नंबर 15, तो वो स्टेबल रहती है एज कम्पेयर टू दी +5 ऑक्सीडेशन स्टेट, because of what, the inert pair effect. We have just seen inert pair effect. However, nitrogen cannot form compounds with +5 oxidation state as it has no d orbital in its outermost shell. See, nitrogen in its outermost shell there is no d orbital, that's why it cannot show +5 oxidation state. Nitrogen will show -3, -2, -1, +1, +2, +3 and +4 only. Now elements of group 16 have NH2NP4 as the outermost electronic configuration. Elements from that group number 16, oxygen, sulfur, selenium, tellurium and polonium. These elements have 6 valence electron, that is ns2 np4, total 4 plus 2, that is 6 valence electron. They have tend to gain or share 2 electron to attain stable octet. The most electronegative oxygen shows maximum tendency to gain 2 electrons and exhibit -2 oxidation state. See, oxygen show minus, most of the case show -2 oxidation state. The most common oxidation state of oxygen is -2. See, other than oxygen, sulfur show -2 plus 2 plus 4 plus 6 oxidation state. But all the element show +2 as a common oxidation state in case of group number 16. Now the group number 17 is halogens. Its outermost electronic configuration is what? Ns2np5. Elements of group 17 are fluorine, chlorine, bromine, iodine and astatine. These are the elements from group number 17. These elements tend to gain or share one electron to attain stable noble gas configuration of Ns2np6. Therefore, they are monovalent and show -1 oxidation state. That will be the common. Fluorine is the most electronegative element and hence it shows only -1 oxidation state. Apart from -1 oxidation state, other halogens also exhibit positive oxidation state of +1, +3, +5 and +7. These oxidation states are possible by the excitation of their outer s and p electrons into d orbitals so that 3, 5 or 7 unpaired electrons are made available for bonding. The positive oxidation state are exhibited by halogens only when they combine with elements that are more electronegative. For example, oxyacids, that is SClO4, and interhalogen compounds, that is IF7. So this is about the oxidation state of the S block and P block elements, that is main group elements. In that we have seen inert pair effect, and now we are going to see electronegativity of these main group elements. So before that, this is the chart. See, very first of this lecture I told you about the chart. This is the chart. See the group number 1, 2, 13, 14, 15, 16, 17 and its electronic configuration, all the elements along with its oxidation state. So now the electronegativity of the main group elements. First of all, what is meant by electronegativity? So electronegativity of an element is its capacity to attract electrons towards it from other element in its compound. That means जो भी कंपाउंड होता है उस कंपाउंड में जो भी एलिमेंट होता है वो उसकी एक स्पेशल कैपेसिटी होती है किसकी, टू अट्रैक्ट इलेक्ट्रॉन्स टूवर्ड्स इट फ्रॉम द अनदर एलिमेंट. उसको क्या बोलते हैं हम, इलेक्ट्रोनेगेटिविटी. So the some important factor which can affect of the electronegativity, that are, first one will be the atomic size. Smaller is the size of an atom, greater is the tendency to attract the electrons towards itself, means higher is the electronegativity. See, smaller the size of an atom, then उसकी टेंडेंसी क्या होती है, ज़्यादा होती है क्या, इलेक्ट्रॉन अट्रैक्ट करने की टूवर्ड्स इटसेल्फ. सो मीन्स उसकी इलेक्ट्रोनेगेटिविटी भी ज़्यादा होती है. वी हैव सीन जस्ट द डेफिनेशन, अबव डेफिनेशन. Now this second one, oxidation state. The electronegativity increases with increase in positive oxidation state. This is because with the increase in positive charge of the cation, tendency to attract an electron increases. As the oxidation state increases, size of an atom decreases. Hence, electronegativity increases. Third one, third one will be the hybridization of the central atom. See, central metal, that means any compound which is having particular central metal atom, uska hybridization. Electronegativity increases with increasing s character of hybrid orbitals. This is because of s orbital electrons are nearer to the nucleus and have more penetrating power. For example, electronegativity of carbon is 2.48, 2.75 and 3.29 for the sp3, sp2 and sp state respectively. Now the fourth one, partial ionic charge. Electronegativity increases with increase in partial positive charge on the atom. Thus, electronegativity of I plus, see not iodine, iodine plus, that means आयोडीन ने एक जो वैलेंस इलेक्ट्रॉन था उसको वो किसी को तो दिया हुआ है, इसकी वजह से उसके पास I प्लस चार्ज आ गया, तो उसकी इलेक्ट्रोनेगेटिविटी 2.4 से एक्चुअल आयोडीन की इलेक्ट्रोनेगेटिविटी कितनी है 2.4, उसके एक इलेक्ट्रॉन देने से उसकी इलेक्ट्रोनेगेटिविटी वो बढ़ जाती है 4.5, दैट विल बी द ग्रेटर दैन दैट ऑफ द फ्लोरीन. फ्लोरीन की सबसे ज़्यादा इलेक्ट्रोनेगेटिविटी है 4. ओके, सो as atomic size of alkali metal is maximum as compared to the other group elements, C group number first and group number second which is having atomic size will be high as compared to the other groups. See, that means see the group number 1 and 2, the atomic size in case of that there will be high. See the values, there is lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, cesium, strontium and barium. These are the elements from group number first and 2. So in case of period, from left to right, the atomic size is decreases, and from in case of group top to bottom, the atomic size increases. So electronegativity from in case of period left to right, electronegativity goes on increasing, and from top to bottom in case of group the electronegativity goes on decreasing. So this is the trend in case of these main group elements. So group number 1 and 2, the electronegativity decreases as we move down the group. See, just I told the trend. See the element hydrogen, lithium, sodium, potassium, rubidium, cesium. See the value 2.1, 1, 0.9, 0.8, 0.8, 0.7. This is the decreasing order of the electronegativity. Then elements from the group number 13 and 14, more electronegativity than group number 1 and group number 2 elements. See, lithium 1, beryllium 1.5, boron and carbon, its value will be increases. So atomic size goes on decreasing from left to right in case of period. So electronegativity increases. It is because they have smaller atomic size, but for group number 13, as we move down the group, decrease in value of electronegativity is not expected. Similarly, in case of group 14, which is includes carbon, silicon, germanium, tin, and lead elements, show irregular trend. It decreases from carbon to silicon. See, from carbon to silicon, the value 2.5 to 1.8, but from germanium to tin is what, or we can say lead, its value again going increases, right? So in case of group number 16, oxygen electronegativity 3.5, sulfur 2.5, selenium 2.4, tellurium 2.1, and polonium 2.0. See the value that will be going decreases regularly. But in case of nitrogen 3, 2.1, phosphorus, arsenic 2, here the value will be decreases regularly in case of group number 15. But in case of group number 14, it decreases from carbon to silicon and increases from silicon to germanium and again decreases from germanium to tin. See the table, in this table group number 14. Why this is happen? Because of the filling of d orbitals in germanium and tin and d and f orbital in case of lead. Due to presence of this d and f orbital, the values will be vary in case of this group number 14. But in group number 15 and 16, electronegativity of elements decreases gradually as we move down the group. This decreases because of increase in atomic size of the elements down the group. Decrease in electronegativity of these elements also indicates change from non-metallic to the metallic nature of the elements. So last group, that is 17, have least atomic size and maximum capacity to attract the electron towards them. See, most electronegative element will be the fluorine. Value will be what? 4. So they are highly electronegative. Fluorine has maximum electronegativity. It decreases gradually. Iodine shows least electronegativity of 2.5. Iodine also show positive oxidation state in few compounds. In that there is ICl3, ICl5. Because of high electronegativity, halogens are non-metallic in nature. So these are the trends just we have seen in case of main group elements. So across the period of S and P block element, from alkali metal to halogens, electronegativity increases with increase in atomic number. It is because of the, for what? First reason is what? Effective nuclear charge change increases across the period. Second reason, atomic size decrease, that is smaller atoms have higher electronegativity. And third reason will be the ionization energy and electron affinity of elements increases. Hence their electronegativity also increases. So this is about the today's lecture. So in the next lecture we are going to start the anomalous behavior of the second period elements. Thank you, dear student.